Download this code and get free GPT-4o from cglib.com, link in the description below. Java Reflection is a powerful feature that allows you to inspect and manipulate classes, methods, fields, and other components of the Java programming language at runtime. One of the interesting uses of reflection is to override methods dynamically, although it's not common practice because it can lead to code that's hard to understand and maintain. However, I will explain how you might achieve something similar using Java Reflection. Overview of Reflection. Java Reflection allows you to 1. Inspect classes at runtime. 2. Access and modify fields and methods. 3. Create instances of classes. 4. Invoke methods dynamically. Use case, overriding a method. While you cannot literally override a method at runtime, you can create a new class that extends an existing class and overrides its methods. However, using a proxy class or a library like cglib or byte can help you create dynamic proxies that can change method behavior. Here, I will show you how to use Java Reflection to invoke a method and simulate the overriding behavior. Example. Step 1, create a base class. First, create a simple base class with a method that you want to override. Step 2, create a child class. Next, create a subclass that overrides the greet method. Step 3, use reflection to invoke the method. Now, let's use reflection to invoke the greet method from both the base class and child class. Explanation of the code. 1. Base class, this class has a method greet that returns a greeting string. 2. Child class, this class overrides the greet method to return a different greeting. 3. Reflection demo, in this class, we use reflection to obtain the greet method from both classes using get method. Invoke the method using invoke on instances of base class and child class. Running the example. To run the example. 1. Compile all the classes. 2. Execute the reflection demo class. You should see the following output. Important notes. 1. Performance. Reflection can be slower than direct method calls because it involves type checks and lookups. 2. Security. Reflection can break encapsulation and can expose private members, which may lead to security vulnerabilities. 3. Maintainability. Code that heavily relies on reflection can be harder to read and maintain. Conclusion. Java Reflection provides a way to inspect and manipulate classes and methods at runtime. While you cannot override methods dynamically in the traditional sense, you can create subclasses and use reflection to invoke methods as shown in the example. For more complex dynamic behavior, consider using libraries designed for bytecode manipulation like cglib or byte.